So what if I told you we could solve one of the biggest mysteries out there? Are we alone? Without ever leaving our own solar system. Well, in this explainer, we're diving into a cosmic detective story. We're on the hunt for life on worlds trillions of kilometers away, using clues carried on nothing more than a beam of light.
But that brings up a huge question, right? How in the world do you smell a planet you can never, ever visit? It sounds impossible. Kind of like trying to figure out what someone's cooking for dinner from across the country, just by looking at the smoke coming from their chimney. The scale is just immense. But the solution? It's surprisingly clever.
And the answer is actually as amazing as it sounds. We don't need to send a probe, we don't need to travel for thousands of years. Instead, we're using a technique that feels a little bit like magic. We're basically smelling with our eyes.
Yeah, you heard that right. We're using light as a kind of cosmic nose. From right here, we can actually catch a whiff of an alien world's breath, its atmosphere. The whole secret is locked up in the hidden messages that starlight carries across the universe.
Okay, so let's get into our first big clue, because starlight isn't just for lighting things up. Nope, it's a message, and it's carrying a secret code that tells a story about every single thing it touches.
So I want you to picture a prism, splitting white light into a perfect, unbroken rainbow. Every color is there, nothing's missing. That's what pure, unfiltered light from a star looks like. It's our clean slate, our pristine piece of evidence before it runs into anything. But everything changes the moment that starlight passes through a planet's atmosphere. The chemicals in that air, things like water or methane, they act like tiny little thieves. Each molecule steals a very specific color of light, leaving behind these thin black lines in the rainbow. And just like that, you have a unique barcode, a chemical fingerprint of that planet's air. Now, this whole technique has a fancy name, spectroscopy. But don't let the name fool you. The idea is actually super simple. We're just learning how to read these cosmic barcodes. If we can decipher the code, we can know exactly what's in the air of a world light years away. But, reading a code this faint, well, it takes a very special kind of detective.
So, let me introduce you to the incredible tool we use to read these barcodes. Think of it as the ultimate smoke detector, but for the entire galaxy.
And here it is, our hero, the James Webb Space Telescope. This thing is not just some powerful telescope. It is a specialized forensic tool designed for exactly this kind of investigation. It's our super sleuth, and believe me, it has a superpower. Webb's secret weapon is its ability to see in infrared light. Now, why is that such a big deal? Because the molecules that are most important for life, we're talking water vapor, methane, carbon dioxide, they leave their biggest, clearest, most obvious fingerprints in the infrared part of the spectrum. It's like they're shouting, "We're here!" but they're doing it in a color our eyes just can't see. So how does this all work in practice? Well, it breaks down into 3 pretty simple steps. First, a distant star acts like a giant flashlight. Second, an exoplanet passes in front of it, and its atmosphere acts like a filter on that light. And third, the James Webb Telescope catches that filtered light and analyzes which colors, which parts of the barcode got soaked up. But here's the catch, and this really shows you how hard this is. The amount of starlight that actually makes it through the planet's atmosphere is tiny. We're talking just 1% of the star's total light. The other 99%? It's completely blocked by the planet itself. We are literally hunting for a signal inside a whisper. The level of sensitivity you need is just mind-boggling. This quote really says it all. The James Webb Space Telescope has to be sensitive enough to feel a change in heat that's the same as a single candle burning on the moon. It is one of the most precise measurements humanity has ever even tried to make. Okay, so we've got our detective and we've got our method. But what exactly are we looking for? What's the specific piece of evidence, the smoking gun, that would make all our cosmic alarm bells start ringing? See, this is the really cool part. We aren't just looking for water or oxygen or a nice climate. We are looking for a chemical paradox, a sign that something is seriously out of balance in that planet's atmosphere. Think about these 2 scenarios. On a dead world, you'd expect the atmosphere to be pretty stable and boring, right? But what if you found huge amounts of both oxygen and methane at the same time? Well, that's a massive red flag. Why? Because those 2 gases literally destroy each other. Finding them both together means something must be constantly pumping them out, keeping them replenished. And that right there is the punchline. This chemical imbalance,
That's our smoking gun. That's the sound of the cosmic smoke detector screaming. It proves there is some active, ongoing process on that planet. And here on Earth, that something, that giant chemical factory making both oxygen and methane, is life.
And you know, this isn't science fiction. This isn't some plan for 100 years from now. The investigation is happening as we speak. The hunt has already begun.
We've got our prime suspects, rocky, Earth-like planets in that Goldilocks zone, where liquid water could exist. We know the exact evidence we're looking for, that telltale signature of chemical imbalance. And we have the method, reading their atmospheric barcodes with the Webb telescope. All the pieces are on the board.
So, for the very first time in history, we've gone from just staring at points of light in the sky to actually analyzing the air of the worlds orbiting them. We are, quite literally, smelling the stars. And the only question left is, what are we going to find?